Sir, you're on mute.
Right. So that means I need to repeat. Okay. What is one thing regarding 404, two units. One is steroidal chemistry, another one is therapeutic agents. So what you can do, you solve the questions which were mentioned at the end of the chapter, end of the each unit. At the same time, you also prepare for 50 or 60 marks internal on uh, uh, 404 medicinal chemistry. Okay, so this is about what is called as medicinal chemistry, what is called as 404. And today I'm starting one more unit, more particularly in the industrial organic chemistry. So previously it was organic synthesis. So now introduction, after the introduction of two units, okay, dyes and one more polymers. Okay, two units are introduced to this 404. So because of that, they changed the title, name of the paper. Okay, but this is nothing but a what is called as a organic synthesis only. So again, we are here also we are discussing about the reagents. Okay, how the reagents are useful in organic synthesis. So this is about the what is the unit 403, more particularly organometallic chemistry. And you know that organo means a carbon containing. So metallic means this carbon will have a bond with the metallic elements. The metal may be a zinc or maybe a mercury or maybe a aluminum or maybe a lithium or maybe a potassium or maybe a sodium or maybe a selenium. So overall, the bond between the carbon, okay, and elements such as magnesium, copper, cadmium, aluminum, okay, all these compounds are called organometallic compounds. I'm not talking about the definition, classification, and all those things. So directly, I will take one reagent that's called organo zinc. Okay, we can say that organo zinc compounds. This organo zinc compounds, how these are prepared and how these are useful in organic synthesis compared to the traditional reactions. So in order to look into the organo zinc, so first we should know what is zinc. You know that zinc is a metal, more particularly a D. I think you are aware about the periodic table. So in the left hand side, alkali metals, alkaline earth metals. After that, D block elements. Okay, below that F block element, and the right side a non-metals are there. So non-metals reacting with the metal. Okay, here the metal is zinc. I think you also aware about the what is called as configuration, electronic configuration. So electronic configuration of zinc. So D10 stands for the electronic configuration of the zinc. It has only one state, more state in the sense oxidation state. So that is +2 oxidation state. So it does not have a variable oxidation state like vanadium, manganese, chromium. Vanadium, manganese, chromium will have a variable oxidation state. But zinc is having only one oxidation state, that is +2. It is less electropositive. I think you are aware about the alkali metals. Alkali metals are the more electropositive elements, whereas zinc is a less electropositive element and acts as a weak nucleophile. So that means only three points we discussed here. So zinc is a D10 configuration metal, and it is a showing a stable oxidation state of +2. It is a electropositive, less electropositive, and act as a weak nucleophile. So this is about a little information about the zinc. Then let's see what is organo zinc. So organo zinc means when an organic compound may be a alkyl or aryl or maybe a ethyl or methyl. When it is bonded with the zinc, it's called organo zinc. So then how one can prepare the organo zinc? So may be prepared starting with alkyl halide. So what is alkyl halide? When halogen is bonded with the alkane. What is alkane? It's a saturated carbon containing compound. Methane, ethane, propane is an alkane. If methane, propane, ethane is substituted with halogen, halogen may be a chloride, bromide, iodide, fluoride. Then the obtained compound is called alkyl halide. Here, so I am taking a RX. RX stands for alkyl halide. So as per the IUPAC, it's called haloalkane, haloarene, haloalkene, haloalkyne. Okay? So these are the different forms of alkyl halide or haloalkane. Both are same only. Alkyl halide or haloalkane is both are same. Haloalkane in terms of IUPAC nomenclature. Alkyl halide in terms of common name or trivial name. Trivial name or common name both are same. So RX is an alkyl halide or haloalkane. So this RX when it is treated with zinc. So zinc here Zn stands for element. Okay. So what is happening here? You know that zinc, okay, it loses 2 electrons. So when it is losing 2 electron, then only it becomes Zn2 plus. So here what is happening? There will be a new bond formation between the zinc and then what is called as R group. Here the R group is alkyl group. So what is happening here? This X is going along with the bonded pair. When X is going along with the bonded pair, R attains a positive charge, then zinc, it will form a bond with its electron. So that is how a compound R ZnX. So that means Zn is forming a bond with the what is called as a R, and also it is forming a bond with the X minus. So this is what is called as R ZnX. So what we can say that alkyl zinc halide. Alkyl zinc halide. So this alkyl zinc halide, it will be in equilibrium with So it will be in equilibrium with 2 molecule of R, 2 molecule of R and Z. So this formation is there, no? 2 molecule of R means 2 molecule of alkyl and 1 molecule of Zn. So this compound is called organo zinc. So just like I think you are aware about organometallic reagent called magnesium, methyl magnesium bromide, ethyl magnesium bromide. It's a Grignard reagent. So for the invention of Grignard reagent, Grignard is a scientist. He got a Nobel Prize. Okay, actually he is not an organic chemist, but he is invented uh, what is called as a Grignard reagent. So here, this compound is called organo zinc. This organo zinc, then what is the byproduct here? ZnX2. So ZnX2 means it's a zinc halide. So overall, what you can say that, so reaction of alkyl halide with the zinc, it leads to the formation of organo zinc. So what, in other words, we can also say that if R is equal to alkyl, we can say that dialkyl zinc. If R is equal to aryl, we can say that diaryl zinc. But more familiar, okay, are alkyl zinc only, dialkyl zinc. So more particularly, maybe a methyl or maybe a ethyl. Methyl zinc, dimethyl zinc, diethyl zinc. So this is one method of preparation of dialkyl zinc. So that means alkyl halide react with zinc and it forms a dialkyl zinc. So this is a method of preparation of organo zinc. So with this, I will go to the next slide. So next slide, I am discussing two more method of preparation of organo zinc. So I will go to the next slide. Right. Right. So look here, this is the second method. So here what I am taking, instead of taking zinc, here I am taking a zinc halide. Instead of taking alkyl halide, here I am taking what is called organometallic compound. What is called R of lithium means alkyl lithium. So alkyl lithium is an organometallic reagent. So what it means? It means that it is possible to synthesize organo zinc starting with organometallic compound. So this is an organometallic compound. Then what is the reaction here? So there will say R lithium means R will be available as a anion, means R minus is a nucleophile. So that nucleophile attacking a zinc and X is going out. How it is going X? X it will form a bond with lithium. X minus form a bond with the Li plus. So that is how LiX is obtained. So in this case, X may be a halogen. Halogen may be a chloride, bromide, iodide. Okay, fluoride is the costly one. Of course, iodide is also a costly one. So easily, commercially, economically viable one is bromide or chloride. Okay. So now, so what is the obtained? It's a alkyl zinc halide. This alkyl zinc halide can react with one more organolithium. So this lithium can form a bond with halide going out as a lithium halide. Then what is obtained? The obtained one is called dialkyl zinc. So what it means? It means that an organometallic compound such as organolithium react with zinc halides, giving rise to a dialkyl zinc or zinc dialkyl. This is the one. So you need to remember that a reagent called R2ZN. So this we can also write it as RZNR. Okay. So what you need to get from this? Zinc is bonded to two R groups. That you have to remember. So then this is the second method. First method, reaction of elemental zinc with the alkyl halide. Second method, reaction of zinc halides with organolithium compounds. And the third one, so reaction of organomagnesium compounds. So RMGX. RMGX is an organometallic compound. This organometallic compound, when it is treated with zinc halide, so it gives mono zinc halide, alkyl zinc halide. This alkyl zinc halide, when it is reacting with one more equivalent of organometallic halide, so gives dialkyl zinc. So dialkyl zinc is also called as alkyl zinc. These are the three methods of preparation of uh, uh, organo zinc. So here, what you need to, up to this I discussed about a general example. So in place of R, you can take any methyl ethyl. Okay. So that's what you can. That means here where R is equal to alkyl. So again, alkyl may be a methyl group, ethyl group. But I am not going for propyl, butyl, means higher alkane. I am not taking it. So I will explain later why I am not taking higher alkane. Of course, I am saying that alkyl zinc. But so that's what. Why I am not saying? Because methyl is the more popular one. Okay. uh, Methylation using methyl zinc, one can go for a methylation. Using ethyl, one can go for a ethylation, but I am not going for higher than that. Okay. So why? Because lower alkyl zincs are more stable compared to the higher alkyl zinc. So that is the reason I am not taking higher alkanes. So now you know that the method of preparation of organo zinc. Okay. Starting with alkyl halide, starting with organolithium, starting with organomagnesium. So that's what you can remember. So product you remember, and the remaining equation, what is balanced equation, that you have to write. So this is about the method of preparation of organo zinc. So in the next slide, I am taking one example. I think you are aware about the symmetrical alkene and unsymmetrical alkene. Okay, I am taking one unsymmetrical alkene in the next step. I will go to the next slide. So look here. If R is equal to H, then it's called a symmetrical alkene. If R is equal to other than hydrogen, then it is a unsymmetrical one. So here, suppose this alkene is treated with borane. So what is borane? BH3 is a borane. What is diborane? B2H6 is a diborane. So what it will do? It will add. Where it will add? It will add to double bond. How it will add? Suppose unsymmetrical means BH2 will add to less ended carbon. If it is asymmetrical, no need of question. The product is same. Okay. So here, what you can observe, Okay, so maybe you need to consider that. Look here, here I have written as a R, but in this I am written as a CH3. Okay, so if it is a CH3 means it is unsymmetrical. Okay, that is the reason B is adding to less hindered carbon. This carbon is more hindered carbon. Okay, so one molecule of uh, uh, borane, uh, what I can say, borane, it will form a bond with this carbon. H minus will add to this carbon. So that means this bonded pair attacking B, H minus attacking this carbon. So that means obtained one is called monoalkyl borane. You can observe that BH3, 3 hydrogen. Boron can give 3 hydrogen to the alkene. So that is the reason trialkyl borane. Okay, trialkyl borane is the uh, intermediate. So this trialkyl borane, when it is treated with dimethyl zinc. So now you know how to get dimethyl zinc. So dimethyl zinc may be obtained from the reaction of elemental zinc with methyl bromide. Then how this is? So Zn will form a bond with the one methyl, and Zn is also forming a bond with another methyl. So Zn will have a positive nature, CH3 will have a negative nature. So then what it will do? So it can this CH3 to this Zn can replace B. B means boron. Then what is the byproduct here? The byproduct here is trimethyl borate. And what is the product? Product is dialkyl zinc. So that means it should be 2. Okay. So this is the 2. Dialkyl zinc means this is not 3, this is 2. And what is the byproduct? Byproduct is uh, trimethyl borane. So this is also a general example. But if we are instead of R, if we are taking a CH3, it will be a particular example. But here, what I am saying it's a propyl group. So propyl means a 3 carbon containing one. So these are the 4 methods of preparation of uh, alkyl zinc. So now let's look into the reactions. So reactions of organo zinc. So look here I am taking the organo zinc. R2Zn is the organo zinc. So to this organo zinc, if we are adding water, so you know that water means the nucleophilic nature of the water is oxygen only. The lone pair or the bond pair can react with zinc. Okay, and otherwise what I can say that R, so alkyl zinc is there, no? R can react with the proton of the water. So goes out as a hydrocarbon. And what is forming? The forming one is alkyl zinc hydroxide. Alkyl zinc hydroxide. Suppose a alkyl zinc is treated with methanol, then what you will get? Methoxyalkyl zinc. Methoxyalkyl zinc. So what it means? The lone pair present on the oxygen will react with this zinc, and one of the R group will form a bond with this proton, goes out as a alkane, and the product is methoxyalkyl alkyl zinc. Suppose this dialkyl zinc, it is treated with acetic acid. So here CH3CO minus, so that will form a bond with zinc. Then obtained one is called acetoxy alkyl zinc. Acetoxy alkyl zinc is a product. What is the byproduct? Byproduct is RH. R is an alkyl, H is then RH is called a hydrocarbon. Suppose a dialkyl compound is treated with an alkene. Alkene or alkyne? It's an alkyne. So what it will form? You know that CH. This proton is acidic in nature. That means C is available as a anion. Anion means it will attack electrophile. Here electrophile is zinc only. So that means there will be a new bond formation between this carbon and this zinc. So that is how a alkyl, I think you know that what is called alkyl, alkynyl, alkyl. So YL. Okay, YL means it's a triple bond one. Okay, alkynyl means double bond one. So here the triple bond one, alkyl one, and the zinc. Suppose same organo zinc or dialkyl zinc, if it is treated with a proton source. So what is proton source means? Acidic one. Means when alkyl dialkyl zinc is treated with acid, AH is an acid. Okay, so what will form? Byproduct is RH. What is the product now? R zinc A. So here A may, for example, A is a sulfuric acid. Then what you can say that HSO4 minus and H plus. So H plus will form a bond with one of the R. HSO4 minus is coming over here. So later stage, what will happen? Again, if this is treated with an acid source, then what will happen? One more R is also going out as a hydrocarbon. So what it means? It means that organo zinc is unstable towards the acid or proton source. So these are the reactions. So what we can say that organometallic, organo zinc react with water to form an hydroxy compound. Organo zinc react with alcohol to form an ethoxy. Organo zinc react with acetic acid to form an acetoxy. Organo zinc react with the alkyne to give an alkyne, alkyl zinc. Organo zinc also react with acid source to release hydrocarbon. So these are the reactions of organo zinc compounds. In addition to these reactions, we will also discuss a few more familiar, not the familiar, application, metallic, organo zinc application. So that I will discuss. So with this, I will go to the next slide. So look here, reaction with alkene. Alkene means double bond. Alkyne. So simple organo. So again, simple organo zinc compounds means maybe a ethyl zinc or maybe a methyl zinc. Do not react with alkene. Simple organo zinc compounds do not react with alkene, double bond. But in the presence of catalyst like zirconium, so Zr means zirconium, Cp2 means dicyclopentyl CP means cyclopentyl group. 2 means dicyclopentyl group. So that means 2 molecule of cyclopentyl moieties are there. So 2 molecule of cyclopentyl moieties are attached to zirconium and difluoride is attached to zirconium. So what we can say that it's a complex. So what you can organometallic complex. I think you are also aware about the coordination complex. A transition complex, transition metal complex. So what is here? Zirconium is bonded with the 2 cyclopentyl group and 2 fluorine group. So what we can say that dicyclopentyl difluorozirconate. Okay, that's what we can say that. Then, so what you need to remember here? So zinc alkyl alone cannot react with a double bond or a triple bond. Zinc alkyl require a catalyst. The catalyst is dicyclopentyl zirconium iodide. So this is the one. Here fluoride. So then what is the product? What is the product formed? So here I think you are aware about the selectivity. Regioselective. If there is a possibility of forming 2 products, if you are able to get only 1 product, then such process is called regioselectivity. So here, so zinc is act as a source of ethyl group. So this ethyl group, it will attack a more substituted carbon atom. Whereas zinc, it will attack a less substituted carbon atom, terminal carbon atom in this case. So then what is the product you will get? So you will get a compound like this. Suppose, so that means this is the advantage, this is the application. So if you want to insert a ethyl group to this carbon, then you have to go for a reagent called dialkyl or diethyl zinc. Suppose if this double bond is treated with HBr, so it is possible to get a 2 products. So Br minus can attack this carbon as well as this carbon. So that means 2 products. When you are treating with a zinc dialkyl benzene, you are getting only 1 product. So that is the advantage. So that too, ethyl group is attacking a more substituted carbon atom. So zinc will form a bond with the terminal carbon atom. So here you can look into that. But again, this double bond is a symmetrical double bond. Symmetrical means same. This group is also same. This group is also same. If it is a symmetrical double bond, then ethyl can attack this carbon as well as this carbon. Product will be the same. Okay, so that is how a product is. So these are the this is about the reaction of diethyl zinc or organo zinc in presence of catalyst. Okay, forming a addition product. It's an addition product. Okay. So with this, I will go to the next slide. So next slide also, I am talking about the application of organo zinc. So look here. So this is one name reaction. So what is happening here? Cyclopropanation. So that means, so by this name reaction, so one can get a cyclopropane compound. So this is the advantage. So what you can observe here, diethyl zinc. So diethyl zinc, when it is treated with iodomethane. Okay, diethyl zinc, when it is treated with iodomethane, so what it will do? There will be a new bond formation between this methyl group and this zinc. So the here what is going out? So one ethyl group and one iodide is going out. So to form this compound. Again, what it will do? Again, one ethyl group and iodide is going out. So then what is the product formed? The product formed is di means a di means what is called as a methylene. CH2 is a methylene. Okay, and dihydromethylene zinc. So dihydromethylene zinc, otherwise methyl dihydromethylene dihydro zinc. So this reagent is called maybe here you can make R as a or maybe you can make K as a silent. Okay, maybe K or R. You can make one what letter as a silent and pronounce it. Okay, it's a reagent. It's a name reagent. Okay, so what will happen here? The double bond. Okay, so overall what you can say that you know that 2-hydro group. So 2-hydro group is a living group. So there will be a new bond formation between this carbon and this carbon, and there will be a formation of cyclopropane. So this reaction is called cyclopropanation reaction. So here I will also take one more name reaction. I will and here so temperature 60-degree temperature. So this is again a catalyst. And C6H6 is a benzene, it's a solvent. And these two, okay, so these two react. How they react? This is the equation. So this equation, what you will get? You will get a one side zinc means dihydro methyl zinc. Okay, so using this, a double bond is converted into cyclopropane, and this process is called cyclopropanation reaction. So with this, I will go to the next slide. Means one more name reaction I am taking. So not the name reaction, few more example of cyclopropanation. So look here, this is a methoxy, and both side double methyl groups are there. So when this double bond also treated with a reagent called diiodomethane in presence of dialkyl zinc, it's a cyclopropanation reaction. So this double bond is converted into cyclopropane. Similarly, this compound is also converted into cyclopropane compound. So normally, so one can frame a question. What is cyclopropanation reaction? Otherwise, write a note on cyclopropanation reaction. Otherwise, they may ask you directly the name reaction itself. So write a note on this name reaction. So you should be able to write all these things. Okay. So here, what you need to remember? You need to remember this compound. Its name is methylene zinc. Okay. So with this, I will go to the next one. Next one is also uh, a name reaction, Simon-Smith reaction. So usually for the 2 marks question, so what is Simon-Smith reaction? So what is Simon-Smith reagent? So this is the reagent. Do you find any difference between this reagent as well as the previous one? Is there any difference? So look here. Here, dimethyl zinc is the uh, dimethyl zinc is treated with iodomethane. So whereas in the previous name reaction, diethyl zinc is treated with iodomethane. So that is the only difference. So both the reagents are useful in the cyclopropanation reaction. Okay, so here dimethyl zinc. So in the previous name reaction, diethyl zinc. So that is the only difference, right? So this double bond is also cyclopropanated. So here you can observe that two double bond. This is one double bond. This is another double bond. So both the double bonds gets converted into cyclopropanation. So this both this reagent react giving rise to this product. So here a double bond can react with this carbon, and also this new bond formation between this carbon and this carbon, this carbon and this carbon. That is how a propanation, cyclopropanation is obtained. This is just like a carbene reaction. You know that carbene insertion, CH2 is inserted to the double bond, no? In same way, this is Simon-Smith and previous name reaction. So with this, I will I will take a few more examples of Simon-Smith cyclopropanation reaction. So look here, this is cyclopropane, this is also a cyclopropane, this is also a cyclopropane, but there is a double bond here. This double bond gets cyclopropanated when it is treated with Simon-Smith reagent. What is Simon-Smith reagent? Dihydromethane in presence of dimethyl zinc. So this double bond gets converted into cyclopropanation. So here, what is the, I think you are aware about double bond. This is the methyl group, and this group is called oxygen and nitrogen. Oxygen and nitrogen in a 6-membered ring is called morpholine. So morpholine, this is a morpholine. So that means a morpholine substituted alky. So when it is treated with iodomethyl in presence of zinc, dimethyl zinc, this double bond gets cyclopropanated. So what is the mechanism is involved here? So Simon Smith. Okay. This 2 electron can form a bond with this zinc. So that is how Zn-I2 is going out. Okay. And this is the general mechanism for Simon-Smith reagent. So what I will do with this, I will go to the next slide. So next is about a few more reactions of organo zinc I am discussing. So look here, addition of carbonyl compounds. So that means when this organo zinc is added to the carbonyl carbon. So here, what is you know that what is called as CH3CHO. CH3CHO is an carbonyl carbon, means acetaldehyde. So here, diethyl zinc, it will act as a source of ethyl group. Ethyl is added to this carbonyl carbon. What it means? It means there is a formation of alcohol. Similarly, you can observe, this is an aldehyde. Aldehyde, when it is react with dialkyl zinc, it leads to the formation of alcohol. So what it means, and here one thing you need to remember, lower dialkyl zinc compounds are more reactive than higher dialkyl zinc. Lower dialkyl zinc compounds are more reactive than higher dialkyl zinc. So here dimethyl zinc is a lower alkyl zinc. So whereas diethyl zinc is a higher dialkyl reagent compared to methyl zinc. Okay, so that means you can remember that lower alkyl zinc compounds are more reactive compared to the higher alkyl zinc. It's a note. So one thing you can keep in mind that organo zinc means alkyl is the source. Alkyl will act as a nucleophile. That alkyl will add to the electron deficient one. So, but two name reactions are there. Two name reactions are cyclopropanation reactions. So, in the first name reaction, dihydromethane in presence of diethyl zinc. In the second name reaction, it's called the Simon-Smith name reaction. In that, dihydromethyl dialkyl zinc is the reagent. So of course, zinc will also, dialkyl zinc also react with carbonyl compound. It leads to the formation of alcohols. So with this, I will go to the next slide. So next slide is about a reaction of alpha beta unsaturated carbonyl compound. This is a double bond and this is a carbonyl compound. So you can also look into that here. So there is two possibilities. What are the two possibilities? So look here, ethyl. It acts as a source of uh, ethyl anion. That ethyl anion, it attacking electron deficient carbonyl carbon, but it does not replace the Br. So again here there is a selectivity, regio selectivity. Okay. So that this is the application, but this is possible in presence of catalyst. So what is the catalyst? So titanium isopropyl, okay, isopropyl group. Okay, tetra isopropyl titanium is the catalyst. So in that catalyst it is happening. And the polymerization. So polymerization means here what is happening? A alkyl group. So this is R. R is attacking this carbon. When R is attacking this carbon, this bond pair will form a bond with zinc. So that is how a product is formed like this. Then afterwards what will happen? The formed product can react with one more equivalent of epoxide. This is an epoxide. This is also an epoxide. How it will react? This bond pair can react with this bond, and this O minus react with zinc. So that is how a dimer is obtained. This dimer can lead to a polymer. This is the structure of polymer. Stereo regular. So that means what you can observe, there is a regularity. So this CH2O regularity, that stereo regular polymer is obtained. So polymerization with the dialkyl zinc is catalyzed by water or alcohol. Stereo regular polymer is obtained. Maybe what I will do, this is about organo zinc, dialkyl zinc. Okay, otherwise, yes, maybe we discussed about preparation of organo zinc. We also discussed about the reactions of organo zinc, more particularly two name reactions. Out of two, one is Simon-Smith, and all the two name reactions are nothing but a cyclopropanation reactions. We also discussed about the reactions of organo zinc with carbonyl compounds. So carbonyl compounds on reaction with organo zinc, it gives alcohol. So using organo zinc, it is also possible to get a polymerized products. So this is about what is called as preparation of organo zinc and its application in organic synthesis. Okay, at this stage, if you have any doubts, you can ask me. If you don't have doubts, maybe one more thing I would like to mention at this stage. So all of you, if you are vaccinated, you share your vaccination certificate, and also try to upload your vaccinated certificate in the old app of Campus Tech. Okay?
Done it already, sir.
You done it?
Yes, sir. Most of us have done.
Then you have to share that information, because I don't have that information. I have to give it to respective persons. Okay?
Most of us have done, sir.
No, I want detail. Okay?
Okay, sir.
So share the information.
Fine, sir.
Okay. Right. That's all. Prepare for the 404 internal. Okay, that's what your present target.
When is it, sir?
I will tell you the date. 404, 50 or 60 marks questions.
Okay, sir.
Right.